Hello everyone, my name is Léandre Lavoie-Hudon, and I'm presenting on behalf of myself and my co-authors. First, a little bit of background on AI opponents in video games. They're usually governed by simple AI techniques such as behavior trees, but AI based on a more complex machine learning technique called player modeling has been shown to be more engaging to players. This approach infers a decision model based on one's previous behaviors as well as the attributes of the situation. This model can then be used in various ways to raise player engagement, for example, by confronting the player with an opponent that uses their own model. The tool we used in the study to model player behaviors was called Cognitive Shadow. It is a pre-existing AI tool created by the company Thales that has shown great effectiveness at capturing decision patterns in other contexts. In this study, however, we decided to take the player modeling approach one step further by using Cognitive Shadow to anticipate and counter the player's upcoming actions instead of just mimicking them. We wanted to answer two questions. Will this work? And will this be more engaging for players? We created a basic strategy game called Wizard Battle Elements to test this in. The human player is player 1, facing off against an artificial opponent as player 2. The game is played in battles, which each lasts 5 rounds. The winner of each round is the player who picks the right elemental spell to counter his opponent. The winner normally deals 10 damage to the loser, but this amount can be raised or lowered based on two changing variables within the game. The winner of the battle is the player who took the least damage. We tested this with 26 participants. They each played 3 sessions of 60 rounds, only being told that they would face an artificial opponent. During session 1, Cognitive Shadow was in learning mode, thus player 2 chose its plays at random. During session 2, Cognitive Shadow was active and helped counter participants' decisions. Before session 3, participants were informed that their opponent was trying to anticipate and counter their strategy. Engagement was also measured at the end of all 3 sessions with a questionnaire. Our most interesting results showed that player 2 was more effective with the help of Cognitive Shadow, winning significantly more battles in session 2 than in session 1, and maintaining that advantage into session 3. In addition, the level of engagement recorded by participants increased significantly in session 3. What we can conclude from these results is that anticipating and countering with Cognitive Shadow can be used in a strategy game to increase engagement, but only when players are aware of this behavior. This can be explained with self-determination theory, which posits 3 basic psychological needs. We believe that our method could help answer these needs thanks to the adaptive challenge it provides and the human-like characteristics it gives to the opponent. Finally, more studies will be necessary to determine if our countering method will work in more complex games. To conclude, we do want to thank the institutions on screen for supporting this research.